Okay, great stuff. So, let us see what's happening here. So this is really about what's referred to as key factor analysis. And here again, what we have is this is relevant costing. We have a shortage of a resource, and this resource, how do I know what the shortage is when I just can't meet the demand for all of it? So, for example, it tells me there's a demand for 10,000 cups and 5,000 plates. Now, if I look here, I guess the question here is that when I look at labor, I spend a pound ten, I charge a pound ten to making a cup, and direct labor is £11 an hour. So really, I know that I'm spending, if you like, a tenth of an hour or 6 minutes, so 0.1 hours to make a cup, right? Because £1 10 divided by 11 as a percentage is 0.1, so 10%. And in terms of this, I'm spending £1 60 divided by 11 divided by 11, and that's 0 point. So I'm spending 0.145 hours to make a plate, because if I'm charging a pound 60 to each plate and I pay my people £11 an hour, that's the amount of time I'm spending. That's the first thing you need to be comfortable with. So I'm just teaching this so you can see what's going on. So therefore, if I was going to make 10,000 cups, well, I would need, right, 10,000 cups times 0.1 hours, which is 1,000 hours. We actually do this question in the in class, and then we would also have, and it's for the plates, you would need 5,000 times 0.145. This is the total amount of time I would need. So this is how I know. I mean, to be fair, they'd give it to you, but you can work it out. 725. So I actually need 1,725 hours to meet this demand. But the question is, how much time do I actually have? It says the company has 10 operatives. So I have 10 people, if you like, who work 140 productive hours a month. So I only have available 1,400 hours. So the question is, how best can I make use of this time? So the argument is, well, make the one that gives you the highest contribution per scarce resource. So who gives us the highest contribution every hour we spend on it, if you like? That's the question here. So the question here is, let's focus, let's look here, let's look at the cups. So my cups, when I look at my cups, I'm going to work up here. My contribution for each cup is £2.50 minus 0.5 plus 1.1. Plus, oh, look at me, almost there, missed that up there. Plus my 0.5, that's variable as well, almost lost that there, plus 0.5. So £2.50. So these are all my, so let me just get that right. This is just show you, this is my selling price, and these are all my variable costs. Variable costs, materials, direct labor, and variable overheads, not fixed costs, right? Allocated fixed costs are not, um, if you like, they're not, these are allocated, they're not, first, they're not divisible. They don't tell us that anyway. So we don't include those. We're just in the short term, so we ignore this, right? Technically a sunk cost. So those are all my variable costs. So my variable costs come to, yes, 50p plus £1 10 plus 50p again. So that's £2 10, technically, isn't it? And so my contribution is £0 40. Yes, make sure you're happy with how I've arrived at. Selling price minus all of these three. And I do exactly the same thing here. Selling price minus all of these three. So that's £3.50 minus the selling price minus the variable cost, which is 0.75 plus £1 60 plus 60p, which is, let's just do that, 0.75 plus £1 60 plus £0 60, which is £2.95. Oops, £2.95, which gives us a £3.50. Oops, sorry, £3.5 minus £2.95, which is 55p. So that's my contribution on its own. But this, what we're looking at, what we're talking about here is, what we're saying is that when we spend 0.1 hours making a cup, we get 40p. When we spend 0.145 hours, we get 55p. So just like anything, imagine you were working and you spend zero point 0.1 hours and you get 40p, or you spend 0.145 hours, you get 55p. The question is, which should I do? Which one is better? What's the better yield? What's the better return? So I need to divide the 40p to see who's giving me. In effect, I just need to, yeah, divide these two things to see who's giving me the better yield per hour, right? Because by dividing this by this, I'll get the situation per hour. So 0.4 divided by 0.1 is £4. So I'm literally getting £4 every hour, because 0.4 divided by 0.1 is 4. 4. So this is the same thing, right, as 4 over 1. Yes. And this is the same thing. So 55p divided by 0.145 is the same thing as 3.79 over 1, right? So my cups are giving me the better return. So I'll make my cups first. I'm basically trying to use these 1,400 hours as best as I can in the short term. So when I make my cups first, I will make 1,000 cups first. And because each cup takes 0.1 hours, I will use up 1,000 hours. And the question is, well, how much time will I have left? Well, I will have 400 hours left to make, I will have 400 hours left to make my plates, right? And it takes me 0.145 hours to make one plate. So therefore, because I worked that out, the question then is, how many plates can I make? And that would be 400 divided by 0.145, which is approximately 2,750 plates. Right? So the task here is very much about trying to find how we best efficiently using that time available to us, who is giving us the best return on our time, if you like. And this is something we apply every day in life, um, really trying to use that as possible. Cool, great stuff. So your answer there becomes D, because that's the amount of the 400 hours left will given that we're spending 0.1545, sorry, will give us 2,750. Cool.